Hello, I'm Pedro Algarvio. It's hard to say my last name in English. So I've been contributing since 2011. Um, Previously, I was a sound engineer, and I started hacking Python just for the fun of it and to keep my brain busy. And so it was basically for the pleasure since 2006 and for profit now since 2015. It's when I joined SaltStack.
Yeah, and I joined the Salt core team in January. Um, Worked a number of different places using Python before that. 2.4 was my first version of Python, and I learned about Salt at PyArkansas 2012. Somebody gave a talk there, talked about these masters and minions, and I thought that sounds pretty interesting. And I liked automation a lot, and of course loved Python. So I picked it up and have been using Salt in one form or fashion ever since, and finally was able to join SaltStack earlier this year. Um, so the uh, presumably the reason you're here is because you'd want to test and perhaps contribute to Salt. Um, if you're not familiar with the Salt enhancement proposal process, it's something that we've been doing in a form or fashion for a while, but we've recently kind of shifted nomenclature to hopefully make it a little bit more clear what those things are for enhancing salt, modeled after the PEP process a little bit. Um, and so SEP number 10 requires tests for merging code. Before that, we were a little bit lax and we didn't really have strict requirements, but now we've got strict requirements. The two main reasons for that is to protect against regressions as well as be able to improve our refactoring process. Um, so you want to contribute. You know we need tests, but maybe you don't know how. Um, Testing is hard. I'm sure we all have been there where we've just wondered what do I need to test. We have a lot of operating systems that we support, different versions of Linux from SUSE to Ubuntu and CentOS. Um, we have Windows and Mac. Uh, Now we've got native minions running on networking hardware. So there's a lot of operating systems. And so that can kind of complicate testing a bit. And running our entire test suite takes a long time. It usually takes about 5 hours right now to run the entire test suite on all of the platforms that we support. Um, so I'd like to start out with some common ground, because if you've been in testing for very long, you know that people can say unit testing and integration testing and functional testing, and they can mean many, many different things. Um, so kind of the terminology, or at least to start, before we even talk about terminology, let's just talk about motivation. Why do we write tests? Gary Bernhardt had a fantastic talk, fast test, slow test, and he talks about these three main goals in testing. So this is the motivation. This is why we want to test. So the number one reason is to prevent regressions. Um, we don't want to fix bugs more than once. That's just terrible. Um, if we see a bug, we should write a test that exhibits the buggy behavior, fix the code to pass the test, and then hopefully we never see that again if we've written the test well. It also helps us to enable refactoring. One of the biggest reasons that we don't refactor code is because it's kind of terrifying. For product like Salt that thousands and thousands of people are using, if we break things, that can be a kind of a significant issue. Um, and as we enable this refactoring, we can improve our design, because if we're not stuck to the existing design, we can say, hey, this doesn't really work well, but I've got tests that are going to tell me if everything is working the way it should. And so I can go ahead and I can improve my design and make it easier to work with, easier to refactor. All of these different things we can change if we've got good quality tests. So unit testing. When we say the word unit testing, what we mean is it tests one thing. Now, testing one thing may require multiple assertion statements. So if you have a if you have an object that is somewhat complicated, some return value, for instance, that needs to return true, it needs to provide a path to something that it changed and do a couple of other things, you're really testing one behavior, that this thing succeeded. But that may mean 3 or 4 different things. So you can have assertion statements for each one of those, and it's still a unit test. It's still testing one thing. Unit tests are isolated from irrelevant changes. They're focused on logic. So what does that mean? If you have code that is tightly coupled to the implementation, that's a problem. If we, for instance, something I've been working recently with is a database library, and we can abstract the particular library we use. We don't need to actually depend that we're using this particular database library, as long as we can connect to this kind of database and we can run queries and get results back. It doesn't really matter that we're doing it with library A or B. As long as we're focused on the logic, that makes it a unit test. You can test first or test last. It's up to you as you're developing. Some people have a preference for test-driven development. Other people just drives them bonkers, and there's no real right or wrong way. It's just what works for you. It's not required to mock anything. If you are writing tests in a well-designed way, oftentimes you won't even need mocks to actually write your tests. They're thoughtfully encouraged, so there are times where you will need to use mocks, but they're not required. One of the places they might be useful is if you have a slow interface that you need to deal with. That would be a place that you could mock. Unit tests are also fast. They should not take even tenths of a second. They should take, some amount of milliseconds. So functional tests, they are similar to unit tests in that they're really testing one thing, but they're a step above, and they're testing this system level integration. So when we say functional testing, we're talking about things that hit an actual file system. Maybe they actually hit a database. They are still testing one thing. They're still going to be pretty fast because they're really just going to be focused on things local to the system. But they can be a little bit slower, especially if there's some network communication involved. But it's not going to do testing end to end. Similarly, mocks are like seasoning. If you over-season your tests, they're going to taste terrible. They should be sprinkled where you absolutely need them. These tests are really primarily for detecting underlying system changes. If a version of a package changes in the system, this helps us detect it, because if the API changes, we want to know about that. And we want to know about that sooner rather than later. We don't want to let that out into production. So functional tests help us do that. Integration tests, these are selected end-to-end tests. Right now, a bulk of our tests, most of that 5-hour time, is actually spent in integration testing. This is what makes it so slow, because we're testing the entire round trip from master to minion and back again. They are especially effective against regressions because we're testing how everything works together. But they're slow, so that comes at a cost. We really want to have kind of select tests for certain scenarios, as opposed to kind of testing every little function call using integration testing. We're not doing it yet, but one of our future plans is to run against actual build artifacts. So when we build our systems, when we build SaltStack, we build the package, we want to be able to run our integration tests against the package. So when people download Salt, they know I'm getting a tested version, and what was tested is what I'm installing. So there's no possibility of something getting broken by the build process. So to review, unit tests, they're fast, they test one thing, and they assume that Salt works. So they're not worried whether or not a master or minion communication is set up. They're just assuming that states and modules and the loader and everything works. Functional tests are still pretty fast. They test one thing. They assume that the master and the minion work, but they're really testing, does this underlying system behave the way that I expect it to behave? Then integration tests are a little bit slower, and they test everything, and they're kind of the ultimate regression protection, because they tell we can actually run, just like you would in real life, a particular state or module or combination of them.
So I'll pick it up from here. Some do's and don'ts with regards to testing in Salt. And let me just say it out loud. These are all examples that we currently have on the Salt test suite, and especially the don'ts, but we still have them. But it's like we've learned, we are cleaning up, and let me just shed some light on what we should do and do not do with Salt's testing. Global level variables on a test module, like simple objects, a string, an integer, a boolean. It's okay. Dictionaries, don't. I'll explain in a bit why not, because this is actually a simple dictionary, but don't. Complex objects, and I say complex between quotes because we can have a dictionary be a complex object, but I'm just focusing on helper functions, helper classes. Yeah, these are okay. Rule of thumb, keep it really simple at the global scope of the module level. And if possible, don't do anything at the global scope level. The reason being is that when we are scanning for a test, everything that's at the global scope will be evaluated. So if you're, for example, testing a network connection to something, that will slow down just getting the list of tests that are supposed to run, as opposed to trying that connection when you're actually trying to run the tests. Salt configuration. You will see throughout the Salt test suite that we lay out some basic configuration just to run a unit test, because minimal configuration is required. At the global scope, don't. And this is not that bad of an example. We've had worst examples, but I just couldn't find one, which means that we've cleaned up after that problem. And I'll explain why in a second. If they're at a local scope, like the setup function of the test, and you're, for example, using the default options and you don't copy them, don't. This is a bigger example. We are adding a reference to the default minion options, and on the next line we are mutating that dictionary. Don't. If you're doing it the local scope and you are copying it, that's okay, and you should do it. Now, the reason why you should not do these kind of things at the global level or even at the local scope level without copying them is. And I went to find some bug reports, but I didn't search that much, but I was involved in some pretty hard to find bugs that only presented themselves when we ran the full test suite, which, as Wayne mentioned, takes like 5 hours. But when we ran that test function, it passed. And so eventually we narrowed down to the problem, which was we were using the default minion options without copying them, and we were mutating them, which means that the following tests that use the default minion options were not using the default minion options. They were instead using mutated default minion options. So, questions about these do's and don'ts? Do you have any? No, right? So this, it's like clear. But we did it. This was in SaltStack suite, and I did some of those too. So if you're thinking on using the Salt configuration for whatever tests you want, and you are thinking about not copying it, okay, these days when I see a pull request that does this actually looks like me. So if I have ever sounded aggressive on a pull request, please forgive me. But I've been chasing these weird bugs for a couple of hours. So me and my fellow developers. So like some example time preparation, like let's set up for developing for Salt. I will go through some slides, don't worry. We have something prepared further along which will simplify your life for that. But you can run it like a Docker, CentOS image. It's especially important that language that we are passing. You should have these days a properly configured machine to use UTF-8. Most systems use that. For example, Docker containers don't stress that much about that, so the default containers do not set UTF-8. So if you try to run tests on a Docker container, the Salt test suite, it will complain. We install basic stuff. So Git to clone, Vim to edit, compiler, and we install Python 3.6 and Python development because we want Python 2 and Python 3 on the host system. And I should now mention Tox and Watnox. And by this, I mean, I guess everyone in the room knows Tox by these days. If you don't, let me know and I can explain. Okay, you don't know? So Tox is like a tool that allows you to run the test suite on several environments. So you define like an environment, their dependencies. It creates you a virtual environment with using those dependencies, and it will run the test suite on that virtual environment. This means that you can prepare your test suite to run against Python 2.7, Python 3.5, PyPy. So you can do a lot of prep work to run your test suite. The reason why I add this Tox and Watnox is that we started out with Tox, but we switched to Nox. Nox is like Tox, but on steroids. The configuration file is not a basic text file. It's actually a Python file. And that allowed us to actually select which dependencies we want to install at runtime for the Salt test suite. So that's Nox. You actually see us installing Python, so Nox Py2. And now you might ask Nox Py2 for those who actually know Nox. So Nox is actually a library that only runs on Python 3. Salt still runs on Python 2, and will still run on Python 2 for a while. And because it still runs on Python 2, we have to test it on Python 2. But we needed the power of Nox, so we actually forked Nox and make it work on Python 2. Of course, the upstream project has moved on, and it's not even considering merging stuff Python 2 related, which I think everyone understands. And so we are actually maintaining our fork of that. For testing Salt, you should actually use our version of Nox, or it will not work. And you clone your salt repository, wait, because by now it has grown quite a bit. And this is how we would run the salt test suite using Nox. So if you actually pass --list to Nox, you'll find like there's more than 400 options for environments. Don't be overwhelmed by that. We just have a lot of options to select how we want to run the salt test suite.
Yeah.
By default,
I was just going to say, Salt supports a lot of different versions of Python and different communication protocols. So we've got Nox environments for all of those. So it makes it look frightening and terrifying because you just see this list scroll past. But like you said, don't be afraid of it. There are a couple, 2 or 3 that you should know about, and then you can kind of focus on those.
Yeah, you should. Most of the time, you will probably just be calling out run tests for now, and -0MQ, which is a transport. If you want to test under TCP, instead of 0MQ, you pass TCP dash and the Python version that you want to test against. 2.7, 3.4, because we still have one distribution that uses 3.4. 3.5, 3.6, and Salt supports up to 3.7. If anyone runs Arch, you might have noticed that Arch has moved on and is actually using Python 3.8. Salt does not yet run on Python 3.8. We have an open issue with that, which will be fixed soon enough. Now, there's an easier way to start doing hacking on Salt, and Wayne actually created a Docker container. If you want to explain a little bit what happens on that container, what they get.
Yeah, so this Docker container, if you want an easy way to like run tests or even just play around with Salt, this container will get you a reasonably modern Salt installation. So you have a master and a minion. You can jump into the container, and there's a /runtests.sh, or not run tests, start servers, I think. It's in the root directory. But there's a script that you can run, and it'll start up your master and a minion. Then you can just start playing around with it, which is really useful if you're trying to reproduce some behavior that somebody has seen. You can run the tests, as Pedro mentioned. The Nox has been installed in it. It also has a few of the tests have the dependencies preloaded in there. Nox has a -- install only flag that will go through the requirements and install all of them. I did that to speed up the load time. It does make the image larger, but if you're running it a lot, then you'll see that the startup time is a lot faster.
Okay, so yes,
it's on CentOS 7. The Docker file should be relatively easy to port to other OSs, but yeah, CentOS 7 was easy and relatively widespread, so that's the one that I picked.
So for example, let's say that you're adding a new module, and your module relies on a dependency. We switched. Sorry, a little background. Previously, we had a state tree that prepared the images that we ran tests against. That's on a repository called salt-Jenkins. That state tree did not pin version dependencies. So we would install whatever the newest thing was. And if you've been involved with Salt for a while, you've noticed that up at least like 6 months ago, we had quite a few issues with instability. Like one test run would pass, the one right afterwards would not pass. And we decided to, okay, let's try to make this as reproducible as possible. And so we actually moved to using golden images. And so that state tree now only installs like binary dependencies from the system. Like if you want to run against a database, you will install the database on the VM. And off of those binary dependencies, which are just system packages that the system distributes, we create then a golden image based off of that. Salt creates AMIs, but we do have plans to, and some of the work is already done, but it's not publicly available. Well, it's publicly available. We just don't support it because we haven't created the infrastructure to run our tests and make sure that whatever someone is downloading, the container is running properly. But we are planning on being able to run the test suite on Docker containers, at least for the most part of the test suite. And so that golden images only gets the binary dependencies. And then one of the reasons why we switched to Nox is because we started pinning our Python dependencies, which means that whenever you run the test suite, you will always get the same Python version for the specific Python library. What we have gained from that is that every test run will always run against the same set of dependencies, whether they're system dependencies or Python dependencies. And that at least made us sure when we tell, okay, this is a problem with the test. While a few months back, we were like, is this a problem with the test? Or is it a problem with one of the dependencies? Or what is it? So we actually stopped, like, if you probably noticed, merging pull requests because we needed this all cleaned up. We have. So since I'm here publicly, please excuse me if your pull request is waiting for a long time. We will get to it. It will get merged. We just do not want to go back to the point where we don't know why something broke. And I guess that everyone will be on board with a decision like this, even though it's taking us longer than we wanted to get to this point. But we will get there. So let's say that we want to introduce a new dependency. I actually started looking for a test that was skipped because of the dependency today, but I couldn't find one. So I'm just like mentioning PyCode style, which doesn't make sense at all for a test, but it's just an example. And I actually echoing that to a static requirements file, and we use precommit to compile these requirements. So what happens with this process is that we will compile requirements for Linux, macOS, and Windows, and for each of the Python versions that we support. So each of them will have its own set of requirements. And so whether it's Python 2.7 or 3. Whatever you want, it will always get that same set of dependencies. What we will have to do when we add a new dependencies like this process, like we edit the requirement that we add the requirement that we want, whether it's for Linux, macOS, or Windows, or all of them, and then we compile the requirements file. There's actually some mocking here, so if you try to compile requirements on Windows or macOS, please forgive me, the process is broken. I use mainly Linux, and I haven't had time to go back and make sure it works with other platforms. If one of your pull requests is waiting on something like this, feel free to ping me, and I will update your pull requests with the new dependencies, at least until we, yeah. Oh no, yes, we can compile for Windows and macOS from Linux. We just, especially in particular in Windows, we cannot compile from Windows to Linux and macOS. And I think macOS is also broken, although I'm not sure here. Hopefully it's not. So let's like a real example real example like migrating. Oh, yeah, migrating the integration test to a functional test. Now I have a spoiler alert, which is it relies on PyTest, which hasn't landed on the master branch. I wondered if I should actually do this on the presentation or show you one of the tests that we have using unit tests from the standard library. But our future is actually moving to PyTest. If you know PyTest, you probably know why. I don't have to explain. And I will actually show you how to migrate one to PyTest. And so, oh yeah, actually now I have this really, really small. So we will migrate an integration from test.file. And it's an actually, so this is the test. It's a simple file, which you might be wondering, okay, why are we migrating a very simple file, a simple test, to a functional? And you will see in a short bit.
And to go back to what I mentioned earlier, that test that's just very small, couple of lines, it's making that round trip. So the master is being spun up. It calls a function on the master calls off to the minion does its work, and returns back to the master. That's not necessarily a bad thing, but every single one of these tests is making that round trip. It's not batching it together in one big state file. It's a single run each time. So you can, if you know anything about network access, you know that gets really, really slow. So by bypassing that for 90% of the cases, we're able to take that 5 hours and drop it down to something much more manageable.
And so to exemplify what Wayne has been mentioning, let's run that exact test, which is an integration test, and use time just to see how much time it takes. And so as you might be seeing now, we've processed a few of the requirements files. This time it's fast because they are pre-installed. But that makes sure that we always use the same dependencies. So let's keep these stats in mind, and let's run the example using functional testing. Let's see, yeah. Okay, I had an error. Just have a second. Why do I have oh yes, I have an error, and let me edit the test file. I saw this error when I was testing this. I just forgot.
Law of live demos.
Okay, this time around, it will not fail. Okay, so let me see if I can have both stats shown. Yep. It doesn't seem like too much of a difference, but this is just one test. Today, Salt has something closely to 10,000 tests. Of those 10,000 tests, roughly half of them are integration tests. So if we shave this amount of seconds for each of those tests, we will cut down from 5 hours to 2.
So there's say that's an order of magnitude, I think, there on time wise. So yeah,
it's a lot. It's a lot. The work that has been going into the PyTest branch, I actually had a few more modules ported, so we know that it makes a difference. It's not in yet because we have decided that when we add code to the master branch, everything will be passing, and we've hit some bumps from the road, so it will land on the master branch hopefully soon. It hasn't landed yet, which I'm sadly sorry for that. Oh, let's grab the shell. Okay, golden images. I've actually explained you the process. It's like the way that we make sure to always use the same system, independent of its version. And Q&A questions. Anyone?
Say, for example, you're writing your own execution modules for your own use in your company. Could you use the same system to test that particular code and then holistically? I'm not saying like writing for the community. I mean, intentionally writing for my company, for example.
So there's two answers for your question. The state that Salt is in today, it's really hard for you to test the code that you use on your infrastructure against Salt. One of the reasons why we are switching to PyTest is because through the use of fixtures, we will enable you to do exactly that. So currently, no. In the short future, yes. You will be able to run your tests for something that you probably don't want to publicize, or because it's tailored to your infrastructure, you will be able to run tests using the way we test Salt, but your execution modules.
So what's being lost with the functional tests? It's just the networking? Is that why it's 10 seconds faster? Or is there anything else?
So with the functional testing, the communication between the master and the minion is not involved. Along with setting up, so the event that a job was published, picking up the job, these are all synchronous tasks. And most of the time that we save is because of that. We are basically calling kind of a minion that is running on that process, going through that function and just returning the results. So it's like instantiating a minion on your shell. It's a limited minion because it doesn't react to all of the events, but it's exactly what happens when you run a job against a minion. So we are calling the minion directly, which calls the function directly and returns the response back to your function directly. There's no networking involved. Most of the time shaved off is because of that. Yeah. Some other prep work that Salt needs to do, but most of the time it's that, yes.
Yeah, and those are good things for us to test, that, round trip communication, just not 5,000 times. Any other questions?
So I'm not sure if this is off topic or not, but I understand that there's work in being able to set up master and minion daemons using the PyTest framework. Is that included in what you've described today, or is that still coming?
Yes. Well, to use PyTest, we actually had to create a PyTest plugin, which is called PyTest Salt. The way we run tests now, we have a script that sets up our minions and masters and then runs the test suite. The plugin that we added to PyTest, which is Salt specific, through the use of fixtures, will start up your Salt master and Salt minion when you need them. So, for example, if you want to run the unit tests, since you're not using the Salt master or the Salt minion fixture, it will not spin up those daemons. So you will be able to separately start the master and the minion. Although the first stage of our PyTest integration, because we need to migrate from run tests to PyTest in a clean way, we are starting all of the daemons from the get-go if we are running integration tests. A little further down the line, we will only start those when we actually need them. But as a stopgap, while we migrate, the PyTest Salt plugin still starts everything up if we are running integration tests.
Any other questions?
How long do you guys think you're still going to support Python 2.7? Is that January 20 next year? Is that when you guys are going to stop?
No,
We'll still have a version of Salt that supports Pi 2.7 out, but I forget exactly what the time is on that. There is one of the SEPs actually that spells out exactly when we'll appreciate that and what that schedule looks like.
It'll be at least a year from Neon, which will be January 2020. So it'd be January of 2021 is when we're be dropping support for that version. The SEP to deprecate Python 2 says that we're going to do that in Sodium, which is the release after January, so 4 months from January. Whether we actually do that or not is a little bit right now dependent on what is happening with the native minions on the network devices, because a lot of those network devices still have Python 2 and no Python 3. So depending on that work, which it still looks like we're probably going to be able to drop Python 2 support, but there's just a little bit of a gray area.
so for the Mac, we are supporting Python 2 until at least 4 months after January 2021.
Somebody had a question.
It was the same question.
Perfect.
Any other questions? Okay, so join us for the Salt testing sprint, which is right after. This was like just getting your feet wet with Python testing. I will be there to answer any more questions and go more in depth for anyone who still has any doubts or questions or just wants to start trying it out. Thank you.